climate change seen in Alaska and the prospect of future impacts. Panelists will discuss the policy implications of climate change here in Alaska that affect our everyday lives, such as how we prepare for and mitigate climate change and what lessons can be learned from past development, and what can Alaska's Indigenous communities teach us and show us about the changing environment that we live in. This is a panel that sits comfortably at the intersection of history and science. It demonstrates that much of what we think of as historical research might also be viewed as good old-fashioned historical research. Accessing the records of our past, listening to the stories of our elders, suggests how dramatically the world has changed around us and how we might blaze a path forward. As part of the Critical Issues lecture series, the Cook Inlet Historical Society and the Alaska Historical Society are proud to have partnered with the Anchorage Museum and the Atwood Foundation. Our hope has been to raise the level of debate and provide a greater level of understanding grounded in history and science to the issues that define our current moment. We've been so pleased with this lecture and the response that we've gotten from it that we are in fact trying to extend it into 2025, and the two historical societies are right now in conversation with what that might look like. But as a heads up, the broad theme that we are kicking around is rights and responsibilities, so certainly relevant, we think. We believe that you'll be impressed with the caliber of national speakers that we'd like to include both at this particular speaker series, but also at the Alaska Historical Society Conference in October in Cordoba in the fall. So stay tuned for more of those details, just by way of closing out the fourth of this lecture series. I'd also like to remind everyone that the Cook Inlet Historical Society is sponsoring one more event for the season. That's in May, organized by Cook Inlet Historical Society board member Laura Koenig. The program, entitled Seward's Follies, The Life and Legacy of William H. Seward. The program will include songs, instrumental music, and dramatic readings, exploring Seward's complicated but undeniable role in Alaskan history, and that will fall on the date of his 233rd birthday. Don't quote me on that. It might be his 234th or 231st, but something like that. So please reserve May 16th to join us here. You will not want to miss this one. It'll be very much like a follow-up to our last year's May program, when we had that really spectacular musical dedicated to the centennial history of the Alaska Railroad. This one will be about William Henry Seward. So, and with that, I'd like to hand it over to our moderator for this evening's event, Molly McCammon. McCammon is an Alaska Historical Society board member and senior advisor at the Alaska Ocean Observing System, and I can't think of a better person to lead this discussion. So Molly, please take it away. Thank you.
Thanks, Ian, very much. And thank all of you for joining us tonight, and for those on Crowdcast. I think we have maybe 40 or so people online, so as we're going through all of our program tonight, if you have questions on Crowdcast, just put them in the chat and we'll get them relayed to our speakers. Global warming, climate change, climate variability, extreme weather, emission reduction, mitigation, adaptation, resilience, geoengineering, climate refugees. You've probably heard a lot of these terms in the past few years. But what do they mean for Alaska? For Alaska in the past, Alaska's present, and Alaska's future. So tonight we're really honored to have two esteemed panelists, and I'll talk, we have one change, who will share with us their perspectives on climate change in Alaska. We'll begin with Rick Thoman, a climate specialist with the Alaska Center for Climate Assessment and Policy at the University of Alaska Fairbanks. Rick also has decades of work with the National Weather Service, and he is just a wealth of knowledge. He'll be followed by Dr. Ken Tape, who is a climate change specialist and research professor at the University of Alaska Fairbanks. And then we had intended to have Jackie Schaefer, the Director of Climate Initiatives for the Alaska Native Tribal Health Consortium. Unfortunately, Jackie had a very kind of a family emergency very late in the day, and she was not able to join us tonight. We're hoping that maybe for the Monday discussion on Olay that she'll be able to join us. So because a picture can be worth 1,000 words, the first portion of our program tonight will be devoted to the two speakers giving short overviews using slides to illustrate their perspectives. This will be followed by a discussion among the panelists that I'll moderate. And then we'll open it up to questions from the audience here and also to questions that you can put in the chat that will then be transferred to all of us so we can answer those. So with that, I will open it up. And Rick, I think you were on tap first. So Rick Toman from the University of Alaska Fairbanks. So thanks, Rick.
All right, thanks very much, Molly, and thanks to all of you. I can't see you with the bright lights here, but I know you're there, and so thanks for coming out, and thanks for joining for those online. So it's always a pleasure for me to visit here to Dena'ina lands. I've had the privilege of living in Fairbanks for decades, a traditional and never ceded land of the Tanana Dene people. So it's always a pleasure to come to Dena'ina country. So Alaska's changing environment. Being a historically minded group, I thought we would jump right in and start with how do we have any idea of Alaska's weather and climate and how that might have changed. And of course, we have the privilege in Alaska, we have 10,000 plus years of indigenous experience in an environment that has changed radically over time. So for instance, we know from Tlingit stories some of the impacts of glacier expansion in southeast Alaska during the Little Ice Age in 1400s, 1500s. We know some of the impacts in 1783 from the eruption of Laki volcano in Iceland, killed a quarter of the population of Iceland. And that is plausibly one of the years without a summer that's well known in Northwest Alaska indigenous knowledge. Some of you in the room, I'm sure, are familiar with the Richardson Highway south of Delta Junction. South of Fort Greely there's a big dome that rises up out of this flat plain, Donnelly Dome. In the languages of the Tanana Valley, the name for that feature translates as Heart of the Glacier. Now, we can think up lots of ways that might have gotten that name, but the most parsimonious explanation is that was named when it was a Nunatak, when it was a hill sticking up out of glaciers. And the geologists tell us that glaciers haven't been there for 14,000 years. Traditional knowledge, generations of experience have seen these kind of changes. All right, fast forward. In the Western way, our very first anything like systematic observations of weather and climate start in Russian Sitka, starting in 1827 and continuing through the rest of the Russian occupation, starting off with several hours of weather observations per day. Eventually it became around the clock. We also have journals, both from Russians and in Northeast Alaska from Hudson Bay Company. So we know, for instance, from the journal kept by Alexander Murray when Fort Yukon Hudson Bay Company store was opened in 1847. We happen to know now from his journal the date that the Yukon River ice went out in May of 1847. But it's kind of those individual little chunks of information. They're fascinating, but it's hard to put together a narrative, particularly because after the sale of Russia, from Russia to the United States, the territory that would become known as Alaska, there were very few observations. The weather observations ended at Sitka. Eventually, the Army established some forts that did some kind of systematic weather observations start evaluation really, from the Western science perspective, the dark ages of weather and climate observation in Alaska. There's continues to be some journal information, but there's almost no systematic observation, some information on things like start and end dates of navigation from coastal sites, but really we know very little in that post-American purchase era. What became the Weather Bureau was established, it's part of the Signal Corps in 1870, was attached to the Army. That's how we got weather observation at forts. In 1890, that was transferred from the Army to Department of Agriculture. The Weather Bureau was established, and that really signaled a change in weather and climate observations in Alaska. We saw an expansion of cooperative or volunteer weather observations using equipment supplied by the Weather Bureau. The Department of Agriculture also established quite a number of these agricultural experiment stations around the state. Most of them were quite short-lived, generally 10 years or less. Many were less than that. But 2 continue to this day. The agriculture experiment in Palmer actually has the longest period of observations at the same site anywhere in South Central. And the agriculture experiment station in Fairbanks, now on the University of Alaska Fairbanks campus, has the longest period of unbroken observations at the same place for anywhere in the state. Observations have been made within about 100 yards of its current location since the summer of 1911. The first Weather Bureau office opened in 1917 in Juneau, and we saw an expansion of Weather Bureau activity in the state from then until the Great Depression hit. And we saw expansion and increased number of observations and observation sites. But in the early 1930s, as budgets collapsed, many of those sites were closed, only to be reestablished in many cases with the advent of World War II, tremendous expansion in the observation network. 1940, the Weather Bureau established a regional headquarters in Anchorage. It had been run out of the Juneau office prior to that. And the expansion during World War II kind of set the stage for our modern place-specific observations. Since about 2000, though, we've had really a sea change. I'm going to get my water. A sea change in the observational network. Automation has almost entirely replaced human beings almost everywhere. And we now have the case where we live in the golden age of weather observations. 6 p.m. Alaska daylight time today. You could find out what the temperatures, the winds are right now at 250 different places around the state. On the other hand, the climate observation network has shrunk dramatically, and we've lost considerable amount of information, especially off of the road system in the last 25 years. So we have this divergence. Tremendous amount of weather information, especially in rural Alaska. We are back to about the same density of observations that we had probably in the 1920s. It's really quite dramatic. So that difference between weather, what's it doing right now, versus climate, the daily statistics, day after day after day. It's not sexy, but it's important from establishing our baseline that we have that continuous record, and that has really fallen on hard times. All right, so here's what it looks like. I don't think I have missed any stations here. This is the entirety of long-term weather observation sites. In this case, long-term means going back to at least to the World War II era. You can see that north of Kotzebue and Bettles, that's 1928 and 1944 there is no long-term climate site except at Utqiagvik. There is nothing at all in the northeast interior. Fort Yukon has very early records, but has never been consistently maintained as a climate site. Even here in South Central, weather observations, climate observations start here in Anchorage in the 19-teens, almost at the beginning of the founding of Anchorage, but they moved around all over the place. There's severe quality issues in the early days. And because of Anchorage's location with the Chugach Mountains directly to the east, Cook Inlet to the west, mountains beyond that, location matters a lot. So, yes, there are observations from downtown, and what we would now call downtown Anchorage, from the late 1920s, then out at Merrill Field during the 40s and early 50s, then at Anchorage International. The difference in climate between those places means we can't put those together. So even though the change in location between Merrill Field and Anchorage International, as the raven flies, isn't terribly far, it is the influence of the mountains and Cook Inlet make them different enough that we don't want to thread them together. That's different, say, in places like the interior, where if you stay on the valley floor, a move of a few miles doesn't make much difference. If you count real quick here, you can see that off of the road system, so west and north of the road system, there are less than a dozen places with observations going back to World War II era or before, and that's not even counting the loss of things like snow data in western and northern Alaska in the last 5 years. So, with this kind of very sparse network over a huge area, I mean, what is Alaska? It's nothing but complex terrain, right? This is really not really what we need to develop a comprehensive understanding of how our climate is changing. So for that, we're going to rely on models. So this is using reconstructed database. This is from the famous NASA surface temperature reconstruction. So this is for the entire state of Alaska, the average temperature for each year since 1900. The way I like to do these, I plotted up the 10 coldest years are blue dots, the 10 warmest years are the red dots. And you can see, if you look at it, kind of blur your vision. Yeah, maybe there's a little bit of upward trend. Certainly the lack of blue dots over in the most recent 40, 50 years is noticeable. There is one warm year, one top 10 warm year way back in the 1920s, but most of them have been in the last 30 years. Now, what do we make of this? Well, oops, I gave the story away. Okay. When people say climate's always changing, to the extent that that's actually a real thing and not just repeating can't, I think this is what they're getting at. The dashed line here is about a 5-year running average for these statewide annual temperatures, and lo and behold, there's ups and downs of several degrees in a few years. That's normal. There are some very noticeable, significant jumps, and there's also some flat periods or even decreasing average temperatures. So I think this is, again, to the extent that it's real. When people say climate's always changing, they're talking about this year to year, every few years kind of variability. When we look at a much longer time frame, so now looking over multiple decades, we get this green line. And here, the trend becomes much more apparent. That year-to-year variability is still there, But let's go back, 2021, coldest year in the last decade. That's this dot over here. And oh gee, that was a pretty cold year. Well, if you just move your eye back in time, and prior to the 1970s, 2021, which we think of as now as a cold year, would have been a warm year. That's the very definition of climate change. What now is, ooh, it's cold, it's been cold. Used to be, oh, it's warm. Very definition of a climate change. All right, so again, because we lack we have very few long-term climate observations, we're going to lean on our climate analysis models here to look at change. So, this is the total change in the 50 years, 1974 to 2023, of the average annual temperature. Now, a couple things I want to draw your attention to. One, Alaska's warming. Gee, you didn't need to come here to hear that. But I think what is really outstanding of this, Alaska's a big place. Warming, the amount of warming over the last 50 years has varied dramatically. With the warming there on the western North Slope in excess of 8 degrees for the annual average temperature, whereas in the southeast interior, temperature has increased less than 1 degree. No place in Alaska has cooled at all in this 50 years. But the regional variability is really, really dramatic. And that is, I think, very important going forward as we plan for a warmer future. Understanding that whatever, I mean, we can come up with how much is Alaska warmed? We can come up with that, but that may or may not be relevant to your needs, your community's needs, because of this tremendous variability around the state. So I think that's really important. You, of course, have already guessed, or you know why we see these kinds of differences. Why is the North Slope down through the Bering Strait warming faster than most of the rest of the state? Sea ice loss, sea ice thinning, changes in sea ice seasonality is driving a lot of that. Also, decreasing snow cover season. Interesting warming there in southeast Alaska and far northeast British Columbia there. That is a little bit more of less obvious explanation, but I'm fairly sure that is tied to changes in the seasonal snow cover as well. Okay, total precipitation. So, precipitation is rain plus, however much, take the snow that falls and melt that down, so the water in the snowpack. That's what we mean by precipitation. So it's the liquid coming out of the sky. This now, precipitation in Alaska at low elevations, at communities that you could choose to live in, varies by almost 2 orders of magnitude. About 5 inches or so, or at least that was the historical average up on the North Slope, to over 225 inches, say, at Whittier. So I express the change here as a percent, change of the percent of normal, to try to help equalize that huge range in temperature. Now this, of course, looks very different than temperature. First of all, we see there are some small areas. The east side of the Kenai Peninsula, the west side of Cook Inlet show a little bit of drying. A large chunk of the state, including much of southeast and the eastern and central interior, that white space is basically no significant change in the total annual precipitation. However, different story up on the slope and across much of the west coast where there's been an increase. I've already told you why that is. A lot of that is tied to the decreasing sea ice changes in sea ice seasonality. Got open water instead of ice, you got more water evaporating into the atmosphere locally there, so that's driving some of that. Okay, so temperatures are warming everywhere, big regional differences. Precipitation is increasing, except on the North Slope most of the changes are not big yet. Over the 50 years. 50 years. Why did I pick 50 years? Well, one, because it's a nice round number. Two, it's the better part, not the whole part, but it's the better part of an adult working memory. So some of you, of course, well remember weather and before 1974. I do, but I don't have an adult perspective on those conditions, say in the late 60s. I just know the snow was up to my head. Of course, my head was down here, right? So, all right, I think this is my last one here for you. Okay, we looked at temperature and precipitation. How is snow changing? So this is kind of interesting. Looks different than the other two, right? So with precipitation, we didn't see much in the way of change, except some minor changes in South Central. Here, there's a more general decrease in snow, kind of south of about 60 north or so, especially notable across the Aleutians, as well as outer southeast Alaska. Now, the obvious thing to think is that, oh, it would be decreasing in the south and increasing in the north. Doesn't work that way in southeast because the inner channels, of course, are much closer to that cold continental air during the winter. So places like Prince of Wales Island, Baranof Island on the outer coast are seeing the most significant decreases in snow. Large chunk of the state, not much change. Now, I didn't put it up here because I didn't think I'd have time, but since I have a little more time, I will tell you. This is for the whole cold season, September through May. What's really interesting is that over nearly all of the state, except the North Slope, we see that the autumn snowfall has decreased dramatically. Why? Because more of the precipitation is coming as rain, or you can think of that. What used to fall as snow is now coming as rain. But in the midwinter, coldest season, over most of mainland Alaska, at least Kenai Peninsula north, we're seeing an increase in snowfall. That makes sense. The atmosphere is warming, winters are warming. The amount of water vapor that the air can hold is very dependent on the average temperature, so you warm up the winter temperatures a little bit, can hold more water vapor. Storms come along, they can turn that into snow. So at the moment, over most of mainland Alaska, north of 60 north, what we're seeing is the decrease in autumn snow is being offset by the increase in midwinter snow. Eventually that's going to change, of course. But at the moment, we've changed the seasonality of the snowfall, but at the annual time scale, we've still got that. It's still about balanced out. So that is what I have for you. My contact information is there. I do write a Alaska and Arctic Climate newsletter that you're welcome to subscribe to. It is completely free, always will be. And if you'd like to keep up on what's going on in Alaska and around the Arctic with climate, check it out. And I believe with that, I'm going to turn it over to Dr. Tate.
Yeah, thanks for having me. Boy, it is blinding up here. Thanks to the Alaska Historical Society for having me here tonight, and to Molly McCammon for organizing this. My name is Ken Tate. I'm a research professor at the University of Alaska Fairbanks, and I've been studying the effects of these changing climate patterns that Rick's been talking about. I've been studying the effects of that on the Arctic landscape of northern and western Alaska for about 25 years now. And so now you're going to get that in about 8 minutes. Hold on for a second here. Okay. How about that? Cool. This is a great screen, by the way. I've never seen those beavers so big. Yeah, so I've been studying how the Arctic landscape is changing. Let me see, I'm going to grab this other mic. Can I use this other mic? Is that cool? Let's see we'll see if it's got it turned on.
Yeah.
Check, check, check.
I don't think she has it turned on through
Yeah,
there.
that's all right. We'll roll with it right here.
Okay.
Yeah, so I've been studying landscape
Is
change.
it too bright?
No, it's fine. I've been studying landscape change in the Arctic for about 25 years. Sort of how the tundra, right? That's the region that I study. The Brooks Range, the North Slope, and then most of western Alaska. How the tundra's been changing in response to climate change. What we saw from Rick is that those are some of the areas that have seen the most rapid increase and the greatest increase in temperatures. So it's not all that surprising that we see some changes in the landscape. This was in National Geographic several years ago. It was the fold out in the center. And it kind of synthesizes in one graphic a lot of the different changes that are going on, and some of these will be familiar to you. On the left-hand side, you can see wildfires. I won't talk about that tonight, but that's something that I think we all have an intuitive sense. When you have longer, warmer summers, you're going to get more wildfires, and that's definitely something we get a lot of in the Fairbanks. We're reminded of that every several years when we get a bad smoke here. You can see some permafrost thaw and some, we call it thaw slumps, some collapsing ground. There's a receding glacier back there, some thawing ice wedges here in the foreground, and then the right-hand side you can see this shrubby vegetation growing up and the arrival of animals like moose and beavers, and there's even some fish down here. So I spent the first part of my career repeating several hundred photographs across the Brooks Range and North Slope. And by the way, since this is the Historical Society, almost all of the data that I use, or a lot of the data I use, is historical in nature. And what's cool to me is that a lot of that data was not collected for the purpose that I use it for. You know, so this is a snapshot from Ed Sable's field book. He was doing some geology research in 1957. He just happened to snap this photo, and years later he sent me his field photos. And, you know, it says, the field photo says west side of Jago River. And the Jago River is like 120 miles long. So it's a whole fun thing, like trying to get back to these remote places, which are not exactly in your backyard. They're in a far northeastern corner of Alaska in this case. And then getting close enough, and you know, there's a couple things that you can sort of triangulate, and then you get to the location, it's like, yeah, it really has changed a lot. And so there's one of the big changes that is visible in the landscape, longer, warmer, hotter summers, is you get more shrubby vegetation, and that vegetation grows taller and more extensive on the landscape. There's also some permafrost thaw going on in this picture. There's a lot of collapse and subsidence. But that shrub expansion was the primary change that we observed, visible change on the landscape. And that's something that people living out in these communities have also observed over the last 50 years and longer. Receding glaciers is also something that you're very familiar with down here. There are also a few hundred glaciers in the Brooks Range, actually. They're quite small, but there's a picture on the top from Leffingwell in 1907, the USGS guy, and then 2007, I was standing next to Matt Nolan. This is the century repeat, and you can see the glaciers, all the glaciers, there's even some on the far left, are receding. And down in this area, because glaciers are also precipitation driven, you probably have a few glaciers that are still getting bigger, but for the most part, they're retreating down here. In the Brooks Range, they're all retreating, and some just disappearing. This is the Canadian High Arctic, 2005 and 2013. This is what it looks like when permafrost thaws. You've got this planar feature that probably developed over centuries to millennia, and then at some point, you get a warm summer, a couple warm summers, the permafrost thaws, the water flows away, and you get what is called thermokarst. And again, there's a lot of evidence. I'm just sort of giving one-off examples, but I've got dozens to hundreds of examples of all of these. A word about permafrost hydrology. So just thinking about the ways that the landscape, as a scientist, what I've done for 25 years is try to think about the ways that the landscape sort of manifests this change in climate. And it's not that easy to figure out these places unless you have old photos or old measurements, which are very sparse. But one of the things we see is that there's more winter base flow, there's more flow. When everything's mostly frozen in these rivers, there's more flow in these rivers than there used to be. And basically what's happening is, as it warms up, things aren't quite as frozen. So there's more water in these rivers, but also as the permafrost thaws below these landscapes, there's more connections to groundwater. And so there's just a lot more groundwater in these rivers. And that's one of the reasons, I'm going to talk about beavers a little later, but beavers and salmon are probably moving north as well. And that's all associated with the increasing groundwater and the change in plumbing as permafrost thaws. And a couple other things I want to mention. The rusting of the Arctic, you may have read in the ADN the last couple of years. There's several scientists down here in Anchorage that are studying that at APU and UAA. And the rusting of the Arctic is, again, it's a manifestation of that, the fact that the water is no longer perched at the surface. It's sort of connected to groundwater down below because permafrost is thawing out. And imagine the plumbing kind of changing beneath these rivers and beneath these landscapes. Another thing which I don't have a slide for is tree lines moving north in the Brooks Range rapidly. I was just in the lower Noatak snow machining around a week ago. There's seedlings everywhere, and that again is research being done out of UAA and APU showing this expanding tree line. Really, really interesting work. All right, so real quickly, we covered a few of these things. Permafrost thaw, receding glaciers, shrub expansion, and then we've got these critters on the right that are relatively recent arrivals to the Arctic tundra that are moose and beavers. You know, this is a picture I took in the Brooks Range, I don't know, 15 years ago. You know, most of the Arctic is not friendly to moose or beavers. There just aren't many shrubs. The vast majority of the landscape has very, very few shrubs. And it's only down near the creeks that you get a little bit of shrubs here and there. And that is, of course, what moose need. You can see a cow and a calf, a couple little dots up at the top of the frame. That's, of course, what moose need, and probably beavers as well, to get by. So the idea was, or at least my idea at some point was, well, wait a minute, if we have this shrub expansion that's going on in the tundra, if we go back in time 100 years or 150 years, were there moose in the tundra? And I would say mostly there were not moose in the tundra 100, 150 years ago. So here's a map of northern Alaska. The green line is tree line, and the brown lines are the distribution of moose, how it's changed over the last century. And most of that line is drawn from indigenous knowledge. It's, you know, when was the first moose shot in Kotzebue? Well, it was 1951. When was the first moose shot in Noatak? It's 1960. And so by connecting a lot of those dots, you get a pretty good sense for how moose have moved into the tundra. And of course, it's not just the expansion of shrubby habitat, it's also shortening of winter. And that's going to be true for beavers too. Like, that's their bottleneck, right? At the end of the year, the snow's piled up, they have hardly anything to eat, just the shrubs sticking above the snow. Or in beavers' case, it's their cache. And so when that period gets shorter, when winter gets shorter, it makes life a lot easier. Beavers are a whole different ball of wax. I've only been studying beavers for 8 years, but I had the idea that maybe we could look at beaver ponds formation and disappearance in satellite imagery through time to see if they were indeed moving into the tundra. I had no idea. Maybe they were moving out of the tundra. But I was sort of thinking about, like, well, what's the next animal to wander in the tundra? And beavers was a pretty interesting one. Because they don't just respond to these changes, they exert their changes on the landscape. So the top one, that's color infrared photography, which many of you probably remember. That's actually, everything that's red is actually green, right? So that's green tundra. That's the flow direction. That's a little, stream as wide as my office. And then by 2019, the beavers have moved in, and the whole thing is just totally different. And so you can imagine for someone like me and some of my colleagues who are sort of used to squinting our eyes and looking at some of these incremental changes, to see this level of changes, this is from the Seward Peninsula in western Alaska, it was really striking. And so that's happening all over western Alaska and right up to the continental divide of the Brooks Range right now. It's really dramatic. It's not historical anymore. I mean, we're seeing it in real time, which is exciting. This is, again, another one from the Seward Peninsula, 2003. You can see this little stream, and then by 2016, wholesale changes. Indigenous knowledge has become a much bigger part of our research, and it's really too bad that Jackie Schaefer couldn't make it here tonight, because I'm sure she could do the topic justice. But because I'm looking at because I've been studying the last 10 to 150 years in northern Alaska, and there's not a lot of written records, obviously, we rely heavily on Indigenous knowledge, and I definitely appreciate the holistic perspective. You know, so much of science is very, academic science is very siloed, a lot of specialization. I might be an exception to that. I'm sort of a jack of all trades, master of none, but so I have a real appreciation for the holistic perspective of Indigenous knowledge. So to summarize, not surprisingly, warming air temperatures are changing the Arctic landscape, you know, almost all aspects of it. Permafrost, vegetation, the duration of snow cover, as well as the amounts, which Rick was showing us. Wildlife are responding to those changes. And then this last part, I didn't really talk about beavers a lot, but what's exciting about beavers is they're not just responding, they are exerting these really dramatic changes on the landscape and really changing everything about those streams. Our models show that by 2050 or 2050 or 2090, depending on what model you look at, the entire North Slope will be colonized by beavers. And here's the thing. If you went into the Bureau of Land Management or the Department of Natural Resources and you said, I want to get a permit to dam every stream on the North Slope, you'd get laughed out of the building. But that is actually what beavers are in the process of doing right now. So it's pretty dramatic. I think that's about all I got. And I'd love to hear what you guys can add to the discussion. Thanks.
I think what we decided to do is we're going to show you Jackie's slides since we have those, and then they'll be part of the recording too, even though she isn't here to narrate them. So unfortunately, so let me just do slideshow here and play from the start. We have this here. So I'm just going to go through these. So Jackie she's really worked a lot with the Alaska Native Tribal Health Consortium. She's from Kotzebue, so she talks a lot about Alaska Native people being the healthiest people in the world and having this diverse history, 15,000 years of traditions and culture. And a lot of that, the majority of that has been an oral culture passed on. 500 generations deep, which is a lot of generations. That's a lot of family history. And that's everything from using the snow, using the water, using fish, resources from the land. And here, this is a number of pictures, I think, of her growing up. I know that's one picture of her father, John Schaefer. Yeah, I wish she was here to tell us about it. But I'm hoping that at the Monday show, the Olay discussion, that she'll be able to join us then. There's also a lot of cultural traditions using plants for food and for medicine and for other purposes. And so we have a lot here of all the berries, Labrador tea, ockpicks, and then also the resources being used for food and food security, whether it's moose, caribou, fish, seals, whales. And of course, another huge issue in rural Alaska now is coastal erosion, kind of that double whammy of permafrost thaw, and then with the lack of sea ice protecting coastal, the coastline, there's just a lot more wave action and storm action that's affecting rural Alaska, especially western Alaska and northern Alaska. So you see a lot of this. A lot of the villages in western Alaska are the ones highest at risk due to climate change in Alaska. And there is a report that's coming out soon called the Unmet Needs Report, and that I think is going to be released in the next month or so. That will be documenting a lot of this. So, okay, those are Jackie's slides. And we're now going to kind of change a little here. Danny's going to come here and help us. We're going to move this, and We want this to be an open discussion with you all, with us, and with those online. If you have any questions, comments, if you could put them in the chat, and Danny is going to relay them to all of us. So, did you need this, or do you want, is this one of ours? Okay. Okay. Just got it. Okay.
I want to point out, we moved this table with all these glasses of water on it. Didn't spill a drop.
Thanks for that, Rick. Is this on?
Oh, not yet. Hold on.
Okay. Not yet.
Okay, how about now?
Okay. So I'm going to start out because the Historical Society is sponsoring this. So I'm going to ask Ken and Rick, what do you think is the biggest lesson that history has taught us so far in terms of understanding, preparing for, and adapting to climate change in Alaska? Who wants to start?
Hello, hello.
Mm-hmm.
All right. So, what does history teach us? I think history has a lot to teach us, but I think, arguably, in my mind, the biggest lesson it has to teach us is that as Alaskans, we're gonna find a way through. Why? Because we have to. We have 10,000 years of history of finding a way through. Will it be easy? No. Will it be painless? No. But we'll find a way through. Because it's home, right? It's home. We have to make it through. I think there's some other lessons to be learned. Planning for things that we don't have experience with. Beyond our collective memory. We don't know when those kind of extreme events are going to happen, but we know they're going to happen. History teaches us that those are going to happen. So I think history can really inform our future as a community, as individuals, as a state, even in the face of changes that have no direct analog in the past.
No, you. Go ahead.
That's above my pay grade, but maybe we can put it out to the audience.
I don't know if there's anyone there who wants to contribute something to that. Not yet. They're shy. We need to warm them up. What do you think are the lessons that Alaskans can share with the rest of the world in facing climate change? Ken, you have thoughts?
Go ahead. I'll go. All right. So we used to maybe a decade ago or so, we used to say that Alaska is the canary in the coal mine. We're experiencing changes of the impactful nature that, say, the lower 48 would see in the future. We're probably beyond that now, in the sense that those impacts are happening in the lower 48. They're happening around the world. So I think in that sense, Alaska, maybe if we want to, we can get on our soapbox and say we told you so. But maybe more productively, hopefully we can be an example of, yes, these changes are happening, yes, they're impactful, but we're finding ways, individual, tribal, community levels, to get through them and build a life that works, that's sustainable and healthy for our communities going forward. It's not easy, but I think we have a chance to do that.
Yeah, I'd just echo that and say that there's an opportunity to give the lower 48 a sort of advance warning on a lot of these things. Of course, as Rick said, they are now happening water problems and fires in the western U.S. and things like that that are really impacting people. Maybe I think people are starting to wake up to that, but I agree that we're really at the forefront of this. Of course, we have also vast expanses that are largely unoccupied, but even so, I think the lessons that we learn and the way we can sort of react to this adversity will be helpful for those outside.
So, okay, George, do you have a comment here
Well, a question.
or a question?
If we, the state of Alaska, remove the natural gas that's in the ground on the North Slope today, what should they watch out for as they do that to minimize the impact on climate change? Should they all burn the natural gas outside of the state, or is there a danger to bringing it up and transporting it, or it has no effect on the climate change?
I'm not sure we have the expertise to answer that, but
Can you rephrase for the people who are online? They can't hear unless it's in the mic.
well, he had a mic, so they should be hearing, correct? Yeah, they should be hearing.
Good, thanks.
But yeah, I guess the question is, what are the effects of removing natural gas
From the ground and shipping it out of the
from the
state.
ground and shipping it outside of the state? Yeah.
So from the climate system perspective, it doesn't matter if you burn that natural gas, doesn't matter if you burn it on the North Slope or in Japan or in China. It's being burnt, that's going into the atmosphere. Atmosphere is well mixed, that's soon distributed around the globe. So in that sense, it doesn't matter where it's burned.
Okay.
Okay. Yeah, another question here.
This may be kind of silly, but climate change is happening down south and they're losing their shorelines and so on. How many Southerners can Alaska support in the future?
So the question is, climate refugees, will we be seeing climate refugees in Alaska because they're all escaping high insurance rates and lack of and coastal erosion outside? I'm not sure. I don't know. Do you want to answer that? So far, the migration patterns are not coming that much coming north. They're all heading south still. But Rick or Ken?
So you know what? So the point that you make is well taken. However, for many people, Alaska is still very far from family, from what they're used to, and so for many people, when you put all of the factors together, they may choose to not migrate as far. But that's just, obviously, that's not a climate science question. That's just my answer as a Alaska resident.
So we're not going to become another Hawaii, in other
But
words.
Canada will close. Canada will not be available to.
For people to move to? Yeah, from the United States. Yeah, so they may be looking for other places, but they may be looking more in the interior states of the lower 48 and not so much the coastal areas where the majority of the U.S. folks live, really close to the coast, something like within 30 miles of the coastline. There's just a huge number of our population that lives there, and that's experiencing a lot of these changes. So, yeah. I want to talk about that, though, in the sense of extreme weather events, because that's the other thing I think that we see a lot more of, and what kind of effect extreme weather events. Are we going to see more of those in Alaska? I know the prediction is outside. They're seeing more hurricanes, tornadoes, things like that. What about in Alaska?
So that's actually a really interesting question. Just in the last 4 years, of course, we have seen quite a number of extreme weather events here in Alaska. Torrential rains producing the fatal landslides at Haines in 2020 and this past fall at Wrangell. Here in Anchorage, back-to-back near record high snowfall. Northwest Alaska has been exceptionally wet for the last 4 years with severe erosion problems. Ken was talking about Noatak. The Noatak River is eating into the landfill and threatening infrastructure there. Combination of both thawing permafrost and increased rainfall and snowfall the last several years. An interesting thing, though, that I'll use this to bring up is that what we think of as extreme events is clearly changing. For instance, some of you may remember the cold weather from late January, early February. In the Fairbanks area, it got to 50 below one day, and it got to 40 below, I think, 6 or 7 days. I'm so old that I remember that would have been completely uninteresting. That would have been a run-of-the-mill Fairbanks winter. But not only were people complaining about the cold, but it actually was impactful because it hasn't been that cold lately. And so it exposed lots of cold weather flaws, if you will, that 50 years ago, those would have been exposed every year, and so it wouldn't have happened. So what the definition of extreme weather is clearly changing, even as we get these unprecedented precipitation events and their impacts. And then we're getting what used to be cold doesn't happen, and what used to be met is now really cold and has impact.
Matt, I like that.
Yeah.
Yeah, good old-fashioned cold. Was it like that in Anchorage down here this winter? Cold spells?
0,
Yeah.
10 below.
Yeah, I'm originally from Fairbanks, and the 80s, that was sort of normal weather. I'm going to get these wrong, but I think my dad said when we gained at Fairbanks in the early 80s, maybe 14 days of 40 below per year and maybe 4 days of 50 below. Like, that just is incomprehensible now. So, yeah.
Well, I was in Fairbanks one winter, and it did not get above 40 below for the entire month of February. This was in downtown Fairbanks. It wasn't on the hillside downtown, but that was, and every week, certain things started breaking apart. The first week everybody survived. The second week, some people's old cars started not working as well. The third week, people's furnaces started going. By the fourth week, it was getting a little dicey in Fairbanks. So yeah, but we don't see that now. I'm curious, Ken, because of your focus on landscape and wildlife, and you've really looked a lot at what's happening in the Arctic. How does that relate to changes in landscape and wildlife kind of more globally?
Well, I think the patterns that are occurring in the Alaska Arctic are, well, for example, they're occurring in northern Canada as well. So, I run a coordinated group called the Arctic Beaver Observation Network, and we had people from across northern Canada and northern and western Alaska together about a month ago. It's all the same stuff there, First the moose showed up, and now the beavers are showing up, and it's very unfamiliar. Not so much the moose part, but definitely the beaver part is something that's very unfamiliar. Well, as Cyrus Harris said, who is from Kotzebue, we're not beaver people. It's a new critter, and that's really important to me as a scientist, because our records don't go back that far. For all I know, beavers have been pulsing in and out of the Arctic every couple hundred years for thousands of years. But when someone like Cyrus says that, it carries a certain gravity that's worth a lot. But yeah, a lot of the changes that are going on in the Arctic, I won't say I divide them, but some of them have more local significance. and some of them have more global significance. So, and this is important when you're talking to people about climate change, right? When you're talking to them about, oh, well, you know, the shrubs are expanding a little bit, or, you know, why do extra shrubs matter to someone living in Florida? Why does permafrost thaw, you know, matter to people living far away? It's kind of an abstract idea and a bit hard to drive the point home. But yeah, global issues like biodiversity, permafrost thaw, and changes to the carbon cycle, feedbacks to climate. I think of those as more, you know, global issues. But then you have local issues like beavers moving into these areas and blocking spawning streams and possibly adversely affecting water quality. So when I think about these changes and trying to communicate the importance to people, sometimes I think of them in those terms, you know, local versus global.
Okay, we've got some audience questions here. Pat?
So I'm interested in the intersection of science and politics. And just from this winter in Anchorage, it's my observation that unless it's a local matter, politics doesn't happen. I mean, there's no change. So we saw in Anchorage, suddenly we realized we needed to strengthen trusses on roofs, and we realized we needed better technology to get rid of the snow in the roads. And that's pretty much as far as climate change has come, or has affected any changes that I can see. Molly, I'm sure you know more, but so is this what we have to wait for disasters to happen locally, and then people say, oh, I didn't like that, let's do something about it?
Well, I think that is a natural part of the human condition to respond when a disaster occurs. And I would say some of the biggest changes that we're seeing right now due to climate change is in the ocean, and it's what's happening with our fish populations, which is a huge change all over the state, except maybe the sockeye run in Bristol Bay, which is having the opposite impact. It's having huge runs there. But that's about the only place that's seeing that kind of change there. But yeah, big changes in the ocean and the resources in the ocean, which a lot of us in Alaska depend upon. So, but yeah, I think you're very, very right there. Do you want to answer that?
Yeah, I mean,
Disaster.
Well, just the human condition thing, you know, and sort of communicating this issue to people is difficult. You know, it either has to affect you directly, right? Or maybe someone who's 1 or 2 degrees separated from you immediately. So it has to have sort of an immediate effect. Otherwise, the reasoning somehow just doesn't always get through. So, yeah, just, you know, communicating to someone living in, I don't know, Tennessee, why this is an important issue is tricky. You know, I find if I'm talking to that person, then it might work because I actually study this stuff, and well, that's a pretty close connection, but they don't necessarily know anyone who's immediately experiencing these catastrophes, you know, so I think that's pretty tricky. But the fewer degrees of separation, that seems to be the way that people are most likely to change their mind.
Can I tell a story?
Yeah, go ahead.
It would not downplay the power of cognitive dissonance either. We don't experience something but don't make the connection, and I'll illustrate that with a personal story. So the Tomans are a very numerous clan in south central Pennsylvania, and many of my cousins, historic of my age, you know, they wore short pants from April to October, always, always, always. And it's a pretty conservative area. What's this warming? What's this global warming? It's always gotten hot here in the summer. Well, you know what? They don't wear short pants anymore in the summer because they now have ticks. They have always with some low-level ticks, but now it's endemic. You go out in the woods, you can't do that in shorts. And so, they're Tomans, they're not dumb. They put on long pants. But that connection. Why are there more ticks? Well, it's not getting as cold in the winter. They're over the higher survival rate in the winter. And so I don't know what the answer to that is, but that's an important factor. People are seeing changes, and they're taking actions to mitigate those changes. My cousins are wearing long pants when they go out in the woods, but making that the connection of why is where we need more work.
That's great.
Thanks for that story. Let's see, I think the gentleman behind Jim fall there. And then the woman in the green jacket.
Thanks. Rick, in your presentation, you said that you think that when people say dismissively that the climate is always changing, that they're referring to these several year kind of trends in high or low temperatures. But my impression has been that when people say that, they're referring to the fact that there have been ice ages in the past, and then, in far distant past, the Earth has experienced times when it was warmer than it is now. And they're using that to dismiss the idea that its current climate crisis is human caused. And I'd be curious just to know what other people think. Do you think that when people say the climate is always changing, do they mean every few years, or are they referring to what they've, read and seen about ice ages and back when the Earth was warm during the dinosaurs?
I think both.
Probably both, but yeah.
Yeah, I think you're absolutely right. It's a continuum, right? From the we had warm weather in the 1960s too, and to the yes, there was dinosaurs in Alaska, so it had to be warm kind of thing. That's the whole continuum.
I think the lady in the green jacket right there, Kayla, you had your hand up? No, not you. You. Yes, you.
My question is around the relationship between Alaska's extractive industries like oil and possible decoupling of, given the fast pace of climate change in Alaska and the dependence of Alaskan economy on oil, do we see that changing at all going forward? And how is that relationship strengthening or weakening or staying the same, given all of the new science on climate?
Well, I know that the state economy used to be 85% based on oil taxes. And now it is something like, 15%, 20%, and the majority is coming from the permanent fund. So, which was based from oil extraction. It's the savings account. So there has been a definite change there in terms of our dependence on direct extraction, current extraction. So that has changed, but I know that it's still the largest. We don't have an economist here with us, but it is one of the largest job creators in the state, at least currently. But I think a lot of younger people in the state are looking at what are other alternatives, but then I think other people say, well, we still are going to depend on, we need oil for some things, so why let Texas develop it instead of Alaska? So there's a lot of policy questions there, which I don't think we're prepared to answer, but there's certainly a lot of debate and discussion on that. So thank you. I think we have a question on the chat. So Danny?
Yes, David Ramser would like to know, with Russia being an international pariah these days because of Ukraine invasion, are holes being created in data gathering which may impact how climate change is addressed across political borders?
Do you want to answer that, Rick?
I'll start.
I've got a comment on it, yeah. And Ken, you might. Go ahead.
So for some climate information, basically everything that is gathered by satellite, which is a lot, that is unaffected by the internal politics of any individual country. So that is available. Additionally, as we saw throughout the Cold War, even with the current situation, basic meteorological and climatological data continues to be exchanged by Russia with the rest of the world. So that in situ station-based observation are still being exchanged, and that hasn't really changed materially in the last 2 years. So some of that information is pretty much as it was in 2021. But there's a whole class of information that Ken will be happy to talk to where this loss of information is very significant.
Yeah, absolutely. A lot of research programs from all corners of, from everywhere, research programs that were underway in northern Russia just ceased. We got colleagues at Alfred Wegener Institute in Germany who were doing extensive work over there in northern Russia, and that had to stop. I've got a colleague. And, okay, so everyone shifts over to North America, but that only works if North America is representative of northern Russia, right? So you've got this whole part of the Arctic, like most of it, I would say, right? Northern Asia, that all of a sudden is not being studied. So yeah, there's some definite data gaps, and I think it's, it's good that Rick was saying that there's a lot of remotely collected data and some of this in situ weather data that we're still getting, but there's vast stores of permafrost in Yedema, right? This very ice-rich permafrost in northern Russia that, we're losing track of. So that's definitely going to be some big data gaps in the future.
And I think one of the areas that we're really seeing some big changes, David, is in the Bering Strait region, because this is shared by Russia and the US, and just the increase of traffic going through the Bering Strait now. And if we know kind of what the populations look like on our side of the waters, but whales and seals and migrating birds, they don't really stay on a border. They don't stay one side or the other. They kind of crisscross. And so if you were to have any kind of an incident, such as an oil spill or some kind of a traffic accident, it'd be really hard to know exactly what the impacts are going to be on wildlife and on resources, because we don't have a lot of that shared knowledge right now on the Russian side. So there was a big effort with the US and Russian Coast Guard that was happening. There's supposed to be, in fact, this summer is supposed to be an in-water oil spill response test with US and Russian assets, and that all got canceled. So there's been a little testing of US assets, but we don't have that Russian perspective. So that part, I think, is a big loss. And one of the interesting things before Ukraine, we were having these science corners that were sharing different information with biologists from across the border from Russia and the US. And we hear a lot about kind of the northward migration of fish in particular, and salmon in particular. You can see all 5 species of salmon now on the North Slope. Not in large numbers, but you see them there where before they weren't. But for some things like birds in particular, it's not a north-south movement. It's actually seems to be an east-west movement. And a lot of the populations that are seeing declines on our side of the border, on the Russian side, they were seeing large increases. So they weren't seeing the same kind of thing. So what does that mean? Is that a change of the food population, the prey population, or what? It's really hard to know there. Another question? Okay, question, and then Ian will come to you. But, okay, go ahead, Danny.
Shayna Loshbaugh says, here's a question for the Weather Service, but maybe the speakers have pertinent info. It used to be possible to look up history notes on particular weather stations, which included temperature extremes for those sites and what year they occurred. But with the new administration in 2016, all that history data disappeared. I'd hoped it would reappear with the Biden administration, but it hasn't. If I follow the history links about Alaska stations, they don't work, are circular, or go into weird things like the history of hour-by-hour readings over the past week. If I follow every possible link looking for the data, eventually I get a message saying that I should email the head of Alaska's NWS office. Can we get this valuable data back online and updated?
Well, so luckily we do have an employee of the National Weather Service in the audience. But I will give the optimistic response first. That data is all there. It's all online. It's all publicly available. If you could get an email, I can point them to an easy to access source for historical climate information.
Okay, thank you. Ian?
Thank you. So I really appreciate the discussion. Obviously, I'm coming from the humanities. I'm an historian. So one of the debates in humanities circles is over this term Anthropocene, and I'm sure you've all heard of that. And it seems like it's divided humanities scholars whether or not we're living in the Anthropocene, which again is a geological epoch, and people are. Scientists, I think, sometimes maybe raise their eyebrows saying, well, why are humanists kind of naming a geologic epoch? That's up to us. And so I'm curious to hear your views. Are we living in a new geologic epoch that is called the Anthropocene, or is it still sort of premature to turn that page from the previous, or where do you just kind of stand on this word that has kind of entered the lexicon over the last, 10, 20 years or so?
Either of you have an opinion on that?
I bet you Rick does. I haven't thought about it too much. I saw an article a few weeks ago that the geology people got together and said no.
They said no, that's right.
Right. And I didn't get very far into that article, but my gut impression is that we're in the Anthropocene.
The humanist is raising his hands, cheering. Okay.
Well, we certainly know that we are seeing changes in the physical environment that are being entirely driven by human activity and will show up in the geologic record. Things like the by geologic standards, instantaneous increase in CO2. So I'll leave it to the geologists to determine if that's worth an epoch, but clearly we are making changes at a scale, at a rapidity that seems geologic in nature.
Unfortunately, we don't have Jackie here to speak to this, but we did have a discussion last week about, and the question was, given rapid change, a lot of traditional Indigenous knowledge has depended upon just knowledge that has been passed up through generations. Because change is so rapid, how much does the past how much can you rely on that past now? Because it is changing so quickly. And we had this discussion that it's not just the environmental change, but it's also the economic change, the socioeconomic change, the fact that the Arctic has rapidly changing human activity. In my lifetime, I will probably see an ice-free Arctic, even if just for a day, one summer. But I would never have imagined that 20 years ago, that would be possible. And what does that mean for when you look at the Arctic Ocean, and where is the straight line for shipping from Europe through the Bering Strait?